We continue delving into the building process with a focus on the assembly with elements. Alignment and accuracy are the unsung heroes of timber construction. Millimeter precise cuts are essential to ensure that timber elements fit together like puzzle pieces. This precision affects not just the stability of the structure, but also the ease and efficiency of the assembly process itself. Let's look at a case study from Pfalz, Germany, where a Pinksty from 7080 was converted into a showroom. Faced with a deteriorated structure that was hard to finance for renovation, the architects F&P Architekten opted for a practical solution. F&P Architekten used prefabricated cross-laminated timber, CLT, to create a new structure that was carefully craned into the existing building. This inner structure doesn't touch their original facade but helps maintain its integrity. The new windows align with the original openings. A straightforward yet effective design choice. We think this is an upscalable solution in inner cities. Sequencing is a complex ballad of logistics and planning. The order in which elements are joined can affect the structural integrity, the speed of construction, and even the final cost. It's essential to have a well thought out sequence, often added by digital software to guide the process. Cover Inside the Backyard in the inner city heritage of Amsterdam serves as a remarkable case study. Nestled in an urban landscape, this project capitalizes on prefabrication methods to overcome spatial constraints, offering insights into the adaptability of modern timber construction. The prefabricated solid wood shell is 12 meters high with 5 different floor levels. It was assembled in 2 parts due to spatial constraints and was lifted over the existing building with a mobile crane. The tight tolerances in assembly were managed expertly, and the system uses a tongue and groove connection for installation, almost like a piece of furniture. It took 3 months for engineering and production drawings to be produced, 4 weeks for off-site production in Germany and Leiden, and just 2 hours for on-site assembly. Here is a view of the final result. The facade is clad in silver grey painted Accoya boards with open joints. Moving on to our next case study, we explore the Metabolon modular houses in Cologne, Germany, a prototypical approach towards sustainable housing. Led by a team of experts, the project aims to realize 2 experimental housing prototypes. In this detailed look at modules M1 and M2, we see how the construction system is geared for both modularity and reversibility. These features enable a more efficient use of materials and facilitate future adaptability for deconstruction. Let's go into the assembly process of this prototype. In this first step, the groundwork is laid. The base stairs and technical rooms form the foundation on which the modular timber elements will rest. Once the base is ready, the timber structural system is piece by piece carefully placed on top. The precision required here is a testament to the project's digital projection chain, which allows for a near perfect fit between elements. It is a dry stack system. The final layer of assembly involves cladding and windows. The assembly on site speaks to the project's goal of illustrating resource-saving methods. Each timber element has been pre-engineered for efficiency and sustainability, making the on-site process more of simple assembly than traditional construction. Here you can see a photograph of the construction site in progress. Metabolon aims to push the boundaries of sustainable housing, combining space-saving designs with multifunctional use of space. By integrating a continuous digital production chain, this self-built system stands as a research demonstrator of an innovative, energy-neutral, and sustainable architectural approach. Let's now dive into the tolerances needed in timber construction. Wood is not a static material. Working with wood means dealing with its natural variability. Swelling and contraction are factors that must be accounted for in the assembly process. The type of wood, whether it's hardwood or softwood, is just one factor. The specific part of tree the wood comes from also impacts its behavior. Engineered wood products like laminated veneer lumber or cross-laminated timber are manufactured to have much more predictable and reduced rates of expansion and contraction, making them often easier to work with in terms of tolerances. Tolerances in timber constructions are the allowances made for these natural behaviors. They are the calculated buffers that allow wood to behave naturally without compromising a project's structural or aesthetic integrity. Different joinery methods have built-in tolerances. Traditional methods, like dovetails, allow for some movement, while modern techniques using metal fasteners can be more rigid but may require adjustments over time. The LVL X-Fix wood connector is designed to simplify timber-to-timber assemblies in construction projects. This double dovetailed wedged coupling is typically made from laminated beech or birch, specifically suited for cross-laminated timber or CLT panels. In a nutshell, the assembly process is a three-step endeavor. First, CNC mill the mortises into our CLT panels. Next, insert the first part of the X-Fix connector into these mortises. Finally, drive the second part into the first with a hammer, locking them into place. The system is self-tightening, ensuring perfect alignment and eliminating the need for traditional fasteners or adhesives. Here's the end result: a secure, strong joint with no visible fasteners. The tapered shape of the X-Fix allows it to self-tighten, providing a perfect fit for even large format ceiling panels or wall parts. While timber may be lighter and easier to work with than other materials, safety remains paramount. Proper protective equipment, rigorous training, and site-specific safety protocols are non-negligible aspects of timber assembly. While weather can significantly impact a project's timeline, especially with moisture-sensitive timber, innovative solutions like weather protection systems are here to help. Imagine an overhead crane integrated with a modular tent, shielding the construction site and timber elements. This setup allows for efficient assembly while maintaining a dry and safe environment, thus ensuring both the project schedule and the material's longevity are secured. In Berlin, we see an example of modular timber assembly. The lightweight nature of timber allows for innovations like this, where pre-assembled models can be quickly put together on site, reducing both time and cost. As we venture into the realm of modern timber construction, one technological marvel stands out: robotic assistance in assembly. Let's break down the journey from digital design to robotic production. It all starts with construction drawings, which have transitioned from paper to digital platforms. These drawings are then translated into robotic motion plans. Here, every millimeter and every angle is meticulously calculated to inform the robot's actions. Then comes the assembly phase, which includes setting up fixtures, loading materials, positioning them, and finally welding or tying them together. Once the components are assembled, they are delivered to the site, ready for rapid installation. On the other hand, there are also now robots developed by the Design Institute for Computational Design and Construction, ICD, in Stuttgart, with the ability to move in three-dimensional space and perform multiple tasks, from scanning the site to aiding in material assembly. Imagine a future where robotic spiders scuttle through construction sites, assisting in the assembly process. Such advancements are not mere science fiction, but potential game changers that could make timber assembly more efficient and even more precise, especially in difficult to reach areas. Before the assembly on site, some timber constructions take the extra step of pre-assembly. Take Innovation Fabrik 2.0 as a case study. The V-shaped facade elements are meticulously pre-assembled in factory settings. These factory conditions allow for high quality control and precision, crucial for the complex geometry of the V-shaped elements. Even the metal fasteners that will eventually secure these V-shaped facet columns are tried and tested within the factory environment. The focus here is to ensure absolute alignment and structural integrity before they even make it to the construction site. Production drawings lay the blueprint for the structural floor elements. These detailed diagrams are critical for guiding the factory pre-assembly process. Innovationsfabrik 2.0 also used factory pre-assembly for its structural floor elements. By doing this off-site, they've drastically reduced on-site errors and speed up the entire construction process. Once pre-assembled, these facade elements are ready to be shipped. This pre-assembly ensures that once they reach the construction site, it's essentially a plug-and-play situation. And the payoff is evident in the on-site assembly phase. In the case of Innovationsfabrik 2.0, each floor level of the facade elements was assembled in just 15 days. Compare this to more traditional construction methods, and the time-saving advantage of pre-assembly becomes abundantly clear. The level of prefabrication is not only accelerated construction, but also made the process of assembly cleaner and more efficient. In summary, assembling timber elements is an intricate blend of traditional artistry and cutting-edge innovation. From diverse joinery techniques that range from classic to contemporary, to the crucial need for alignment and accuracy in constructing robust structures. We have discussed the importance of sequencing and planning, the challenges of working with a natural material that swells and contracts, and the paramount importance of safety on the construction site. We also touched upon the adaptability of timber, which allows for real-time modifications during the assembly process. Finally, we peered into the future to consider how automation and robotics are becoming integral to timber assembly. As we close, ask yourself, what could the next chapter in timber assembly look like? Elegance by the expression of elements of timber.